Let's read this problem together here. It says, back in 1997, way back in 97, the New York Times discussed a recommendation of a special panel concerning mammograms for women in their 40s. Now, it's known that about 2% of the women in that age group, 40 to 49, develop breast cancer in their 40s. But the mammogram used back then for women in that age group had a high rate of false positives and false negatives. In fact, here's what they were. The false positive rate is 0.30, and the false negative rate is 0.25. So false positive, 30%, what this says is 30% of the time the mammogram comes back positive, but it's really false. You really don't have breast cancer. False positive. Comes back positive, but you really don't have the breast cancer. And then the false negative comes back negative, or 25% of the time. The test comes back negative, but that's false. You really do have breast cancer. The mammogram says, no, you don't, but you actually do. All right? So now here's what we want to know. If a woman in her 40s goes in and has a test and it comes back positive, what's the probability she actually has breast cancer? Right? So typically you would think that, okay, if the test comes back positive, you probably got breast cancer. It's likely. Let's see what Bayes' theorem tells us. So I'm going to write Bayes' theorem here, but in terms of what we have here, I'll put the letters we have. If a woman in her 40s has a positive mammogram, what's the probability she has breast cancer? So how about this? What's the probability of having cancer given that you get a positive result? So Bayes' theorem, big fraction here, tells us this. Now, we know on the top you reverse them. The probability of a positive result given cancer times the probability, and the way it goes, what do you put here? You put the first one, okay? Probability of having cancer. And in the denominator, we always put the probability of the second one, what's given. So this is going to be the probability of getting a positive result. Now, let's look at these and see what we have, if anything. All right, so do we have probability of having cancer? Yeah, it says we're in this age group in the 40s. So it says about 2% of women in that age group have breast cancer. So the probability of having cancer in that age group is 0.02. Now, what about this one here? What's the probability of having cancer and getting a positive result? You know, we're going to have to dig this out. So why don't we look back at what we're given here? This says a false positive is 30%. Okay, so 30% chance false positive. That means that you have cancer but get a negative result. So if I wrote that like this, right, I'm coming out of this one here. This is the probability of getting a negative result given that you have cancer, right? That's going to be what? That's 0.30. So that says there's a 30% chance that if you've got cancer, you get a negative result. So what we're looking for is this, the probability of a positive result given that you have cancer. Well, that's got to be 0.70. Does that make sense? If you have cancer, 30% of the time you get a negative result. So the other 70% of the time you must get a positive result. So we do have that number, but we had to kind of go into this problem, dig into it, and get it. So I'm going to write that down here on the left. The probability of a positive result given cancer, that's going to be 0.70. Now we've got this one up here, that factor. We've got this factor. We need a positive result. And I'm going to do this with a tree diagram. I found that Bayes' theorems, the denominators, can usually we can usually find those by using a tree diagram. So I'm going to start here, and okay, so what do you do? What do I put here? Do I put cancer, or do I put positive or negative? Well, here's how I'm going to figure this out. What do you do first? You either have the disease and then you go get a test, right? You don't have positive and then you go get cancer. It doesn't work that way. So this is not what we want here. We know what to put here. This is going to be cancer, no cancer. Now, what's the probability of having cancer? We're given that as 2%, so that not having cancer must be 98% of the population. Now, let's go up this branch here. Suppose you have cancer. You go and you take the test. The test can come back positive or negative. Positive or negative. Now, if you have cancer, the probability of the test coming back positive, okay, that's what we just found out. right? That's 0.70. That's 0.70, and this is the one that was given 30, right? If you have cancer, it would give you a negative result 30% of the time. Now let's get this lower branch here. If you don't have cancer, then you go in and take the test. So what could happen? The test could come back positive, or it can come back. So we need to get this number right here. If you don't have cancer, what's the probability of getting a positive result? We're going to have to go back up in here and search through that. So what does it tell us here? Okay, we already did this one. This says a false negative rate is 25%. Now, a false negative means you don't have cancer. Down here, you don't have cancer, but the test says you do. Test comes back positive. That's a false negative. Test says positive when you don't have it. So we're given that that's 0.25. So this number right here is 0.25. And because they have to add up to 1, that must be 0.75. And that makes sense. There's a 25% chance they get it wrong, 75% chance the test gets it right. So what we're looking for here is probability of a positive. We'll look down here at a tree. How can you get a positive? You can get it here, or you can get it here. So you can get it right here, or you can get it right here. So to get it here, you have to follow these branches here, right? This one and this one. So it's and at times 0.02 times 0.70. So this one here is going to be 0.02 times 0.70, or is a plus. This one down here, to get here, you have to come down this branch and then that branch. That's going to give you 0.98 times 0.25. So let's substitute everything in. The probability of having cancer, given that you got a positive result back in that old test, is going to be, what do we have here? This is positive given cancer. We found that to be 0.70, right? So that's going to be the 0.70, and then this number right here, our multiplier is that one, the probability of having cancer in that age group. That's the 0.02. 0.02. And then the denominator, that's going to be this part right here, okay? So it's the 0.02 times 70, 0.02 times 0.70, which matches the top, right? Just a different order, but these are not going to cancel because we've got a plus here. So you don't cancel common terms, cancel common factors, but these are not factors, plus, okay, the bottom one, which is 0.98 times 0.25. So I did this with Wolfram Alpha, and I got 0. I'll round to 4 places. I got 0.541. 0.541. Okay, that's the probability. If I change it to a percent, just to get a better feel for it, we'll move that over. That's about what, 5.4%? All right, so let's just think about what this says here. Back in 97, under these conditions, under these tests, the woman goes in, gets a mammogram, it comes back positive. What's the probability she really has cancer? The probability is this number, right? Well, how likely is it? There's a 5.5% chance that she has it. Astounding. Right, so back then, you go in, take the test, it comes out positive, so you walk out thinking that you've got cancer, but really there's only a 5.4% that you do have it. It's 95% chance you don't.